truth under penalty for perjury?
I do.
Okay, you can go ahead and sit down.
Good morning.
Good morning.
Please state your name and spell it for the record.
My name is Michelle Ponschke, Michelle Ponschke.
And what do you do for a living?
I am a laboratory manager for the Michigan State Police Forensic Laboratory in Lansing. I work in the trace evidence unit.
Okay, and what is trace evidence?
Trace evidence typically refers to small pieces of materials that can transfer easily between two surfaces. We typically analyze things like paint, glass, fibers, other materials that also can be compared to each other. We're usually comparing things that we know the source of to something that we don't know the source of to see if they could have been created by the same types of materials.
And how long have you worked there?
It'll be 13 years this coming end of March, so just under 13.
Okay. And what is your educational background?
I have a bachelor's degree in chemistry and I have a master's degree in forensic science.
Okay. And do you have specialized training when it comes to paint analysis?
Yes, I do.
What kind of training is that?
The Michigan State Police Forensic Laboratory has an internal training program for all of the disciplines that we do in the trace evidence unit. The paint training program entails a lot of readings and analyzing various mock paint samples. I've also done a lot of comparison cases that are with known answers that trained analysts then examine my work. I also had to complete a competency case with a known answer that then I had to testify on the results in a mock court. There was also an oral test and a written test that I also had to complete and successfully pass in order to do casework.
So is that different from the annual testing that the outside company does?
Yes, so in addition to that, once I got signed off to do paint casework, I also do proficiency testing. It is part of our laboratory system that we get proficiency tested in every type of exams that we do. So we have an outside company send us cases that they know the answer to, we do not know the answer to, and we analyze the samples and report our findings in terms of whether or not the samples came from a similar source or were made out of similar materials. So I do a paint proficiency test every year. I think the first year I did one was 2015, and I have been doing one every year since then and have gotten the right answer every year.
So, so you get the outside company knows the correct answer, they give you the test, and you compare the two samples. Is that how it works?
Yes, that is correct.
Okay, and what are your options when you're comparing two samples?
Usually the outside company provides one known sample and two unknown samples, so two question samples, and the goal is to report out whether either of the question samples could have been painted by the same paint source as the known paint sample. So it could be that both question paint samples were painted similarly to the known. It could be that one was and one was not. It could also be that neither of the question samples were similar to the known. So answers vary every year, and it rotates between architectural paint samples and automotive paint samples, so the paint samples vary every year as well.
Okay, so there's a distinctive difference between those two types of paint?
Yes, that is correct.
Okay, and I think you said you've done this 15 years, this testing?
No, my first test was in 2015, so it would be about 10 or 11 tests.
Okay, and your rate of success there?
100%.
100%. Great. All right. At this point, we would tender Ms. Ponschke as an expert in paint analysis.
Court's already made its ruling. Thank you.
I add that you will be so certified.
Thank you, Your Honor. All right, I'm going to ask you some questions about paint. I mean, obviously, I think we all can know what paint is basically, but from your perspective as a chemist and a paint analyst, what do you know about paint that the general public doesn't know, generally speaking?
Sure. So paint typically is made up of a solvent, of some binders or one or more binders, additives, and maybe some other contacts, but pigments as well, sorry. So by the time that I'm analyzing it, I'm usually looking at it in its dried state, so the solvent at that point has evaporated, in which case I'm looking at the binder, additives, and pigments, and I'm using various types of instrumentation to compare those binders, pigments, and additives to see if they could be similar to each other or characterize them, as it were. So paint has a lot of different features to it that we can analyze and compare, and also is mass produced, so one type of paint cannot be absolutely identified as the source of another type of paint because it is so mass produced, but we can determine whether paints are similar or dissimilar because they can be made so specific for their uses.
Okay. And just for the record, I'm showing the witness people's proposed 300. So you already covered this a little bit, but what is the purpose of you comparing paint samples?
The purpose of comparing paint samples usually is to verify whether a question or known sample could have been painted similarly. It also can be used to corroborate witness statements or eyewitness statements. We also are using it as characterization, so sometimes there's, agencies just want to know what type of paint it can be, so we can just use our instrumentation to verify the types of paints that are present in various places, so it can be used as kind of an investigative lead. In cases of hit and runs, if automotive paint is left behind, we can analyze that paint and characterize it and determine using databases what type of vehicle that paint could have come from too.
Okay. All right, and as you are doing your analysis, what are you actually physically working with?
I am physically working with actual chips of the paint. It can be in the form of paint that I remove from various places. I've been given actual car parts to remove paint from, or I've gone out and removed paint from various sources myself. It also could be chips that an agency has sampled themselves from various places. So can vary in size, but typically I'm looking at paint chips of one or more layers depending on how many times the actual source has been painted. So they can be very, very small, or they can be larger samples depending on what the source is.
Okay. And then you already mentioned there's a difference between automotive and architectural paint. Are there other types of paint that you can put in general categories?
Yes, there's also types of paint that we can talk about in terms of like mechanical paint, so tools. Think about your pry bars or other tools that you would have in your garage or your barn. Those can be painted and have a different type of paint. Another type could be non-automotive, so paint that's on boats or scooters or other types of forms of transport, bicycles, that's another type of paint. When I'm looking at paint, I usually categorize it as automotive or non-automotive because that's the easiest, because other types of paint can be used in other forms, and original finish automotive paint typically is only found on automotives.
All right, so you said that you are physically looking at chips of paint. How do you get those samples?
They can be delivered to me by an agency submitting evidence. Like I said, I also can go retrieve some of that evidence, either by going to a vehicle or going to a scene of a crime or other places and obtaining that paint myself. Additionally, I received clothing from victims of hit and runs, and their clothing can be scraped down to determine if there's any paint chips on their clothing that we can then use for analysis.
All right, so let's talk about the chips themselves. Is this slide indicating the size of the chips that you might be looking at?
Yes, so this demonstrates paint chips that could have been removed or were removed from debris. So like I said, clothing can be scraped down. There's a lot of debris that comes off of that clothing. It can be dust particles, fiber particles. If they had been outside, a lot of plant material can be on them too. I look through that debris and pull out any potential paint chips to look at further. So this slide demonstrates various paint chips that were removed and placed on a glass slide, kind of to give you an idea of how small some of those paint chips can be.
Okay. And again, is this further blown up?
Yeah, so that's those same paint chips on that slide, but further zoomed in.
Okay, and again, you just zoom in a little bit more?
That is correct, yes.
Okay. All right, so how do you go about, once you have your samples, how do you go about actually doing the comparison?
So a comparison involves a lot of various steps. The first step is usually microscopy or visual examination that can be done with the aid of microscopy because like you saw, most times I'm looking at paint chips that can be very, very small. So while I can see them with my naked eye, a microscope can help a lot. So usually doing a microscope or a visual examination via microscope first. It can be using an individual microscope or a comparison microscope. A comparison microscope is basically two microscopes with a bridge across, so I can see two different stages of a microscope at the same time and compare qualities of paint chips to each other. Then moving on, if all of these samples look similar to each other, I don't see any differences, I move on to other steps of visual examinations. One step involves fluorescence, so looking at the fluorescence properties of the paint samples. Do they fluoresce? Do they not fluoresce? Are they fluorescing similarly to each other? Again, looking for any differences. If I don't see any differences, I move on and continue moving on through my analytical scheme that then includes instrumentation, that then looks at chemical components of the paint, actually looking at chemical bonds, elemental data, and every step I'm looking for differences in ways that I can rule out whether or not these paints could be similar or dissimilar. As long as I don't see any differences, I continue moving on with my analytical scheme until I run out of instrumentation to use.
Okay. All right, let's go over some of those in a little bit more depth. You talked about microscopy. Can you explain with this slide what we're looking at?
So this is a paint chip that was photographed with the use of microscopy. So on the top, you can see this is an automotive paint chip. So you see all that decorative flake, which is used to give your car that shine and impart color to it. So at the top, that K1 image shows the top-down view of a paint chip, and the image on the right, the K1 with the 4 layers exposed, shows what I am actually looking at when I do a comparison, which is exposing all of the layers of the paint chip and then comparing that to another paint chip if possible. If this was the only paint chip I had, or an agency just wanted to know what kind of year, make, model this could have come from, I would only be looking at this and assessing the various layers and analyzing each individual layer to characterize them. In terms of a comparison, I would probably have another chip that hopefully is similar in color and similar in layer sequence, and I would be comparing and looking at each individual layer of that sample as well.
Okay, so first step, visual microscopy. And if you're trying to compare a known and an unknown sample, and you saw differences between the two, what would you conclude, if anything?
I would conclude that they did not originate from the same source, at least as represented by the known, because all I know usually about the known is the paint sample given to me. So I can't assess the entire known, but I can assess the known as the paint chip is given to me. So as represented by that paint chip, the question could not have originated from that known.
Okay. And at that point, if you say these can't be from the same source, what do you do?
I would stop my analyses, and that would be the end of it.
Okay. And if you can't distinguish, what do you do at that point?
If I could not distinguish differences between them, I would continue on with my analysis. So when I had said hopefully they're similar, that means I just meant that hopefully if I've got 2 paint chips, I like doing my work, so I like keep going. But if they are different at that point, I would cease, and that would be the end of my analysis. If they are similar in all layers, in layer sequence, color, thickness, things like that, then I would keep going.
Okay. And what do we have here?
So this is an example of a microscope that I use in the lab. It's called a stereo microscope. So it provides a high power magnification to look at paint chips under, with a camera on top to take photos as needed. So at this stage of my analysis, I'm looking at various qualities of the paint chip. How thick is it? How many layers does it have? What colors are the layers? Things like that.
All right, so if we're past step 1, what is step 2?
So step 2 would be additional microscopy, but on a higher magnification scale, so I could see more details. This particular slide shows cross sections of various paint samples, so I would now, that previous image that showed the layers exposed, another way to look at it would be in cross section, so I could see all of the layers at once. So these images show an example of an automotive sample and an architectural sample of paint, so you can see all of the various layers that I would be looking at and potentially comparing to another paint chip if I had another paint chip to compare to.
Okay. Is this an example of a comparison?
Yes, so at this stage, this would be looking under a stereo microscope. There's a K or known sample, as we previously saw, and then there are two Q or question paint samples that we don't know the source of, so the goal is to determine could they be similar to the known. Visually, looking top down, they do indeed look similar because of the color, because of the flake distribution, because of the colors of the flake within that color layer. So at this point, I would not be able to tell the difference between those samples. However, when exposing the layers, the known paint sample has a medium gray layer in the middle. The Q1 sample also has that layer and has a similar set of layers. The clear, that decorative flake layer, and this medium gray, as well as that dark gray layer. The Q2 sample, however, has a much lighter gray layer there, which is dissimilar in color. So at that point, I would say that Q2 is not similar to K1, and I would not be examining Q2 any further.
So I got a little bit ahead of myself. All that we just talked about was under the stereo microscope, correct?
That is correct,
And
yes.
that's still, that was all step one.
Correct.
Okay, so you get through the end of that process, you can't distinguish, now we go on to step two.
Correct.
Okay, great. Describe what step two is.
So the next further step would be using a comparison microscope. Like I described, this image on the left here shows the comparison microscope, two microscopes with a bridge across the top, so I can visually examine two microscope stages at the same time. The image on the right is an example of an image taken under a comparison microscope, so that is indeed two different samples that are photographed at the same time under the same magnification. So I can compare under high power magnification using a polarized light microscope, because that's what the two sides of our comparison scope are made up of, which just provides higher contrast, because I'm now looking under very high magnification, so not much light is coming through. So providing higher contrast to see more specific characteristics of the paint. So now I'm comparing side by side a question and known sample, and at this point I could be comparing cross sections, but I also can be comparing actual samples of individual layers of paint as well.
So the left and the right image here that you're looking at, are you saying those are the same or dissimilar?
Those would be considered similar.
Similar, okay. And what other kinds of things can you do with the polarized light microscopy?
So the image on the left is another display of a comparison under polarized light microscopy. As you can see, the sample on the left is black paint, but it also has these blue spots throughout. So that's a characteristic that I would be looking at in the question sample. And the sample on the right there is also black paint, but does not have those blue spot characteristics throughout. So at that point, I would say I think these are different, but I'm going to keep looking because I'm already at the microscope, so I'll look for any other dissimilarities. So then the image on the right then shows these two paints under crossed polars. So if you think about your polarized sunglasses, you're now adding more contrast to it to see any other particular characteristics that might show up better under cross polarization. These particular samples do not have any characteristics that show up better under cross polarization, but it's just an example of another feature that I can use under the microscope to compare samples. I can also do fluorescence. So these are the exact same two black paints examined under various fluorescent lighting conditions. So I'm looking at the color of the fluorescence and the strength of the fluorescence to see, do they fluoresce similarly, similar in color, or similar in brightness. These fluoresce slightly differently. The sample on the left consistently fluoresces a little bit brighter than the sample on the right, which I would say is probably a difference that I would note, but because I have already determined that they have those blue flakes in the known sample that were not in the question sample, this is another reason why I would say that these are from different sources.
Okay, so now is that the end of the second method that you would use to distinguish between paints?
Correct.
Okay, all right. So again, you get there, you see a difference in the known and the unknown. What do you do?
If I see differences, I would stop my examination.
Okay, and if you don't?
And if I don't, I would keep going and move on to instrumentation.
Okay, and is that what the FTIR is?
Yes, so Fourier transform infrared spectroscopy, or FTIR, is examining the actual chemical bonds of the paint. So when I'm analyzing paint, I'm directing an infrared light at the paint sample, and any chemical bonds that can interact with infrared light result in a spectrum with peaks. So each individual peak corresponds to chemical bonds within the sample. So if they have different chemical bonds, their spectra would look different. And if they have all of the same chemical bonds, at least chemical bonds that interact with infrared spectroscopy, their spectra would look identical.
So the first few steps you were actually looking visibly, can I visibly distinguish? And now we're like, can we chemically distinguish?
Correct.
Okay. Is this the instrument that you would use?
Yes.
Okay. And could you explain the graph?
Yeah, so this is an infrared spectrum of a sample of yellow paint from a pry bar. So this is an example of the peaks that I was referring to. All the peaks are pointing down, and each peak corresponds to a wave number or a specific number that corresponds to a chemical bond. So I can determine what the chemical makeup of the paint is based on these peaks.
Okay. And so again, just to be clear for the jury, the peaks are actually the down. So for example, and you tell me this, looking here at 1750 on the scale, is that what you're referring to?
Yes, I believe the peak is labeled 1722, if my eyesight is correct. But each peak that has a label pointing off of it, 1723. Okay. So yeah, the points down are the peaks.
Okay. And you know from your training and experience what that means, that they have a down peak right there?
Yes, so that particular wave number corresponds to a carbon-oxygen double bond.
Okay. And the same with all the other downward peaks?
I couldn't say for sure for every single individual peak. I know some characteristic ones, and in certain areas what peaks correspond with what. The 17 one is a very common one, so I know that one very well. But I couldn't tell you exactly which chemical bonds react or correspond with each individual one, but I do know many of them.
Okay, thank you. All right, and what do the circles represent here, the ovals, I guess?
So these are calling out the individual peaks that I use to help me determine that this paint is made up of a terephthalic alkyd that has urethane modification. Yeah, so that's the binder of this particular paint sample.
Okay.
This spectrum also points out that the paint also contains kaolinite and titanium dioxide and calcium carbonate. That was the other one. So those particular peaks that are circled help me characterize it, the additives that are present in that particular paint.
Okay, so I think this one was binders,
Correct.
and this one is additives?
Correct.
Okay. And what about this one?
So this is a comparison between two pry bars. So each individual spectrum is corresponding to a different sample of pry bar paint. There are no differences between these two spectra, so at this point I would continue on with my analyses if I was comparing these two paints, because I cannot tell the difference via infrared.
Okay. And what's different here?
So in this case, these two spectra, also from two separate yellow pry bars, have the same binder, so they're both made up of terephthalic alkyds, but they have different additives. So in general, these spectra look very similar, but they're ultimately different because they contain different additives. So there are different peaks that correspond to those additives that are present in one and are not present in the other.
So is there an imaginary dividing line between the left and the right side of this slide?
What do you mean by
So
imaginary?
it just looks like the ones on the right are more different than the peaks on the left.
It just corresponds with various chemical bonds, so I would say that there's more chemical bonds that are represented on the right side of the spectrum that are what are causing me to say that they're different.
Okay. And what do the circles and the oval represent here?
So as previously discussed, one of the spectrum contain kaolinite, which are those two peaks off to the left that are in one sample and are not present in the other, so that's a difference. This also shows that one of the samples contains barium sulfate, which are those two peaks off to the right that are present again in one sample and not the other. And because these are both two different types of additives that are present in one sample and not present in the opposite, that means these two paint samples are different.
Okay, what about this slide?
This slide shows again two paint samples. One is from a pry bar and one is a sample of questioned yellow paint, so paint we don't know the origin of. And in a comparison between these two, I would say they are different because they have different binders and additives. So nothing about these paints are similar except for maybe their color.
All right, so we're on to another step now, correct?
Correct.
Okay, and so again, same thing. If you can't distinguish between the two, now we're here to scanning electron microscopy, energy dispersive spectroscopy.
Correct.
Okay. Could you explain that to the jury?
Yes, so SEM EDS is an easier way to say that. At this point, I'm comparing samples under a very high power microscope that uses an electron beam to create an image. That electron beam interacts with the sample, and electrons and X-rays eject from the sample, and I measure those using the instrumentation. Those energies that eject from the sample very much correspond to particular elements. So using that instrumentation, I can determine what actual chemical elements are present in each paint sample.
Okay. And is this the SEM EDS here?
Yes.
Okay. And then the image on the right, what is that?
That is a cross-section of an automotive paint sample that was generated by the scanning electron microscope. As you can see, it's all black and white or grayscale because the image is generated by electrons. So if you've seen an image of a very zoomed in fly head, that was probably an image taken under an SEM. However, if you've seen it in color, that color is imparted later because the image itself generated by the microscope is in grayscale.
And is this a readout from that instrument?
Yes, so this is the energy dispersive spectrum of a layer of paint. So now the peaks are pointing upwards, but each peak corresponds to a specific element on the periodic table.
Okay. So what elements are present here?
Looks like carbon, nitrogen, oxygen, sodium, aluminum, silicon, sulfur, titanium, barium, and iron.
And those are represented by the peaks.
That is correct, yes.
Okay. All right. And so is this a comparison then?
Yeah, so I would analyze both paints and compare their spectra and overlay them, as you can see here, to show that these paints are either similar or dissimilar, and in this case, these paints are similar. They have the same elemental content, and the peaks are of similar ratios, indicating that the same elements are present in likely the same amounts.
Okay. And tell us how this is optimized for discrimination.
So each step of my analytical scheme is used to determine are there differences. And as I keep going, I'm using more destructive techniques that then are pulling at more and more information about the paint that can provide more detailed information about the paint, is what I should say. So adding more and more instrumentation gives more information about the paint that then can give me a better idea of whether or not they are from different sources. So going from visual examinations, do they look similar, down to now the elemental content, are they made up of the same stuff? If they were dissimilar at previous steps, obviously, like I said, they would be done with the exam, but once we get down to the elemental level, it's harder to say whether or not they could have come from different sources, because they're, at that point, I only use exams that show they're made up of similar content.
Okay. All right, so as you reach your conclusions, what are some examples?
So we use an association scale in the trace evidence unit when we're comparing materials. So one of the examination conclusions could be that they're dissimilar, so they did not originate from the same source, which would be an exclusion. I could also say that they're similar to one another, and that they could have originated from the same source or any other source that is similar to this, because like I had said, paints are mass produced, so there are other possible sources of this paint that are also similar that I could not differentiate. It's also possible that I can't reach a conclusion, or samples are too small to do the entire analytical scheme on, in which case I can't reach a full conclusion.
All right, so you mentioned that you kind of have an association scale, is that correct?
Correct.
All right, can you explain how that works?
So when I complete my analyses, I report out my findings, and each report includes a conclusion with something from the association scale to kind of clarify what that conclusion means. So like I said, two paints that are dissimilar to each other on our scale is an exclusion. They did not originate from the same source. There's other levels of association. So two paints that are similar to each other would fall at the middle of that scale, which is a level 3 association, which means that these two paints are similar to each other. In all of the exams that I conducted, I cannot tell the difference between these two paints. However, again, because they're mass produced, there are other sources that could also be indistinguishable from these paints.
Okay, so this is used by the Michigan State Police, your unit?
That
across
is
the board?
correct.
Okay. So let's talk about the specific. So you said that 3 is when you cannot tell the difference. What would be the difference between a 3 and a level 1?
So a level 1 is used when the paints can be physically fit back together, kind of like puzzle pieces. We call that a physical fit. At that point, we would identify that these paints we would say that this known source is identified as the source of the question paint because they fit together. That fit would not be expected between any other paint sources, or two paint samples, I apologize. So that can only happen when we have a physical match between two paint sources.
Okay, so is this an example of that?
Yes, so on the left we have an image of a vehicle hood that had paint missing from it, and various paint chips have now been fit back to the hood. The image on the right is a zoomed in image of that to show a paint chip lined up with the hood, so you can see that the edges align, that there are scratches or striations that also correspond across that crack. So at this point, an analyst would say that that is a physical fit, and that question paint chip originated from the hood.
So you've got a top piece and a bottom piece, correct?
Correct.
And you're saying that one of those is from maybe the scene of a hit and run, and the other one is from the car you're trying to match to. Is that about right?
Yes, that is correct.
Okay. And then because it matches up perfectly, you're saying this came from that car.
Correct.
Okay. Is there any other way to get a level 1 match? Association, I'm sorry.
No.
Okay. So again, what's level 2 now?
So level 2 is a high degree of association. This means that, again, the paints are similar in all examinations performed, but there's a little bit more about the paint that's more rare in the population that they represent. So an example that's provided is samples that have a lot of different layers and are maybe of different colors, or are just more unique in the population that wouldn't be expected between other possible, other known sources.
Okay, so is this an example of that?
Yes, so that's an image of, under the comparison scope, comparison microscope, of two paint samples from a vehicle. There was suspicion that two vehicles came in contact with each other and paint transferred between the two vehicles. So one sample is the known paint from one of the vehicles, and one is a question paint sample from another vehicle that possibly came in contact with the known vehicle. And the clear layer is hard to see under these lighting conditions, but that sample, both samples actually are made up of 9 layers of paint, which is not common in automotive paint. So because both samples have 9 layers of paint and each individual layer of paint is similar, was similar under all examinations performed, this makes it a little bit more unique of an association in that there are more layers that are similar, and 9 layers in an automotive paint sample is not common in automotive paint.
Okay, and so just so we're clear, this what looks like a space between different paint samples. You're saying that is not air?
Correct, that is a clear layer of automotive paint.
Okay, and same for this layer down here?
Correct.
Okay. All right, so what makes this a level 2 is that you've got not just one, but multiple different layers that all match up in terms of their analysis.
Not only that, but because of the population that they originate from, automotive paint, the 9 layers is what makes it a bit more unique.
Okay. All right, so you're saying, I think you already mentioned that a level 3 association, excuse me, is when you can't distinguish. You go through all of your steps, the 5 steps that we talked about, the visual steps, the chemical steps. You can't distinguish. That's where we're at level 3?
Correct.
Okay. And then are you able to tell, for example, like at a level 3 association, the manufacturer of the paint?
No.
And are you able to tell within a manufacturer, if you know like the manufacturer of it, are you able to tell like the batch that this came from?
No.
All right, so let's go over level 4 and level 5.
So level 4 is a limited association, which means that all of the exams were indeed similar. It's just that there's something about them that, about the samples that makes the paint a little bit more common in the population, or that there was something about the sample, maybe one of the question sample was smeared onto a surface, so it's a little bit harder to examine and compare, which makes the association a bit more limited because I can't measure or examine as many properties as I would like about it. A level 5 is an inconclusive, which means that there are differences between these samples, but I can't assess if these differences are due to them being of different sources, or if there's differences because of things like contamination or because of the source of where these samples originated from, things of that nature.
Okay. So if like paint had dirt in it when it was applied, would that be something that would make it inconclusive?
That could be a reason, yes.
Okay. All right, and there are a couple other results that you could return with?
Yes, so these are outside of the associations. Unsuitable for comparison means these samples, I can't draw a conclusion between the two because these samples aren't suitable to be compared to each other. Elimination means that these samples did not originate from the same source, they're different. Inconclusive non-association means that there are dissimilarities between the two samples, and there's limiting factors that prevent me from determining how important these differences are, and it's a safer bet to say that it's inconclusive.
Okay, thank you. All right, now let's turn to this case. Did you examine the tank that's at issue in this case, tank 34?
Yes.
And what did you do?
I collected various paint samples from one end of the tank. I was informed that one end of the tank had been suspected of being welded and painted, so I collected paint samples from that particular end of the tank and along the length of the tank. I believe I collected 6 or 7 samples in total.
Okay. Detective, could you get Exhibit 237, please? Not 237, 301. And hand it to the witness, please. Sure. If you can open it for her. Looking at people's 301, you recognize those things?
Yes, so People's Exhibit 301 is an envelope labeled container LV6. It contains various envelopes that I would have collected. So I have LV6A through G, which are all samples that were collected from the tank.
Okay. So how many in total?
A, B, C, D. So that's seven.
Okay. And you said that you had been informed that there was a weld that was in question. Is that right?
That is correct.
Okay. Did you take any very close to that weld, any of those samples?
Yes, there are two samples that were each taken within an inch or two of the weld on either side.
Okay. And do you know which ones those are?
LV6B and LV6E were both from the weld,
Okay.
or near the weld.
All right. And then did you look at how did you get the paint off of the tank to those samples?
I use a scalpel, basically trying to collect all the way down to the surface of the tank if possible. Different scalpel for every paint sample. Trying to get down to the surface, collecting all of the layers and scraping it into these individual paper packets.
Okay. And were there multiple layers when you scraped with the scalpel?
I couldn't tell when I was actually scraping, but in my exams later, I could determine that yes, there were multiple layers in several of these samples, yes.
Okay. And just referring to the top layer, did you compare the top layers of the samples?
Yes, I analyzed the top layer of the white paint on each of these samples.
And what did you find?
They were all similar to one another. The white paint that was the top layer of each of these individual 7 samples were all chemically similar to each other.
Okay. And then B and E, was there any difference between those samples, the ones next to the weld, and the other 5?
Items LV6B and LV6E had an additional layer that I did not see present in the other samples. There were multiple layers of white paint on most of these samples. However, there was a layer of like a light gray layer that was intermixed within the other layers of paint on items LV6B and E.
Okay, and you say light gray, is that, you observe that color under the microscope?
Yes, so to the naked eye it would probably look white, but under the microscope it looked gray when compared to other white layers.
Okay, and just on those 2, not on the other 5?
Correct.
Okay. Did you compare those samples to some paint sticks?
Yes.
Okay. Detective Drewer, if you could give her 239, 296, 297, and 298. You recognize those?
Yes.
Okay. And what are they?
People's Exhibit 239, 296, 297, and 298 are stir sticks that I received to analyze. Each one, I believe, was obtained from a different paint can or different source of paint.
Okay. And can you tell which source of paint is associated with each of those sticks?
There's a piece of paper with each stir stick that describes where they were obtained from. People's Exhibit 239, the paper involved says sample number 1 taken from item number 163, paint can number 1.
Okay, and what about 296?
296 Says sample number 2 taken from item number 163, paint can number 2.
And 297?
Sample number 3 taken from item 163, paint can number 3.
And 298?
Sample number 4 taken from item number 164, clear plastic container with green lid.
Did you also examine excuse me, a lid from a trash can?
Yes, I did.
Okay. Detective Dreer, could you give her 237? Yeah, go ahead. Okay. Yes. Do you recognize what's in what's People's 237?
Yes, People's Exhibit 237 is a trash can lid that I examined.
And you specifically the paint from that lid?
Yes, so I sampled an area of paint from the trash can lid.
Okay. And so what things that you have up there right now did you compare against each other?
So samples from LV6, the top layer of paint was analyzed, and because the top layer of paint chemically was similar amongst all of the samples, only one of the samples then was used to further compare to the stir sticks.
Okay.
So I used LV6A as a representative sample of that top layer of paint, and chemically analyzed, visually analyzed, did all of my analytical scheme, and compared the top layer of white paint to each of these stir sticks first, and then compared to a sample of white paint on the trash can lid.
Okay. And so when you compared LV6A from the tank to stir stick number 1, which is People's 239, what did you find?
People's Exhibit 239, the stir stick number 1, was similar in all examinations performed to that top layer from LV6A.
Okay. And so does that give you a association level?
Yes, so that corresponds to a level 3 association.
Okay. So now comparing the tank sample, LV6A, to stir stick number 2.
To clarify, People's Exhibit 296.
296, yes, thank you.
So People's Exhibit 296 was also similar in all examinations performed to the top layer of LV6A.
Okay. So also level 3?
Correct.
Okay. All right, so now as compared to number 3, which is People's 297.
People's Exhibit 297 was dissimilar to the uppermost white layer of LV6A. So that was an elimination.
Okay, so that paint that came from that stick was not used to paint the tank,
That top layer, no.
the top layer, right? Okay. And then the stick from 298, the plastic container.
People's Exhibit 298 was also dissimilar to the top layer of LV6A, so also an elimination.
Okay. Now, you also said you compared the tank, LV6A, to the trash can lid, which is People's 237. Did you make an association there?
Yes, a sample of paints that I removed and analyzed from People's Exhibit 237 was also similar in all examinations performed to that top white layer of LV6A.
Okay. So the top layer of the tank, paint sticks number 1 and 2, which is 239 and 296, and the lid 237, all 3 of them had a level 3 association. Is that correct?
That is correct.
Okay. Now, again, I just want to get your opinion on, do you know, does that mean for sure that the paint can that those sticks are samples of, is that a match to the tank or something else?
No, that's not a match, because the match would be that these samples physically fit together. These samples are similar to one another, so they have the same chemistry, they have the same binders, pigments, and additives. However, there are other samples, other paint sources that could also be similar.
So the paint from the can that matches stick number 1, you're saying it could have been used to paint the tank?
Yes,
Okay, but it could have been some other paint that was similar in visual inspection and all the chemical properties.
that is correct, yes.
And do you know how many other paints there are in the world that would meet that criteria?
No, I do not.
Okay. Do you know if it's if can number 1 is a Rust-Oleum? Do you know how many cans of Rust-Oleum paint were made that match that can number 1?
No, I do not.
Okay. And do you know whether there's another manufacturer that uses a similar enough process to make a paint that would be indistinguishable from the Rust-Oleum can?
I do not know.
Okay. So you're saying that it could have been used, that can of paint, but you don't know for sure there could be some other paint?
Correct.
Okay. Did you make any reports in this case?
Yes, I did.
All right. All right. That's all I had at this time. Thank you. Oh, here they are. They're underneath. All right, showing you it's been marked as people's 202, 203, and 253.
People's Exhibit 202, 203, and 253 are all reports I authored in this case.
Okay. And we would move for admission of those at this time. Oh, we already did. Thank you. All right. That's all I have. Thank you.
Ms. Ponschke, good morning.
Good morning.
So I want to take you to a report that is not in evidence, I believe, and that's the report that you used when you went to the scene. So you went to the scene on February 25th, 2025. Is that correct?
That is correct, yes.
And if you need to review that report, please let me know. And then that's when you sampled some of the paint, correct?
Yes,
And you chose the places to use your scalpel to take the paint off.
correct.
Ms. Saylor, would you pull up Exhibit 100, which is our page 105, please? And I'm going to ask you to show us where you pulled the paint samples from. Well, while that's coming up, I'll ask you a few other questions and then we'll go back to that. So when you were doing your work, sorry, I just wanted to make sure you were looked like you were kind of organizing things up there. Some paint adhered to the plastic wrap. So there was plastic wrap around the tank. Is that accurate?
Yes, that is correct.
And then some paint adhered to the plastic wrap when it was taken off?
Yes.
You didn't use those samples, though, correct?
No, there were areas of the tank where paint did remove from the tank onto the plastic wrap. However, those areas were noted, and areas sampled from included not those areas as much as possible, so that samples taken of the tank were as representative as possible.
And then also there were some stickers on the side of the tank?
That is correct, yes.
And then some of those stickers were peeled back as well, correct?
I don't recall.
So would looking at a copy of your transcript when you earlier testified be helpful?
Yes.
And I apologize, Ms. Saylor, I believe that you took up the transcript, but I should ask you to take up the report. So if you want, there you go.
Yes, so some stickers peeled back once the plastic wrap was removed.
So this tank had been wrapped in plastic. When the plastic was removed, some paint was removed. You said that, correct?
Correct.
And then also some of the stickers pulled back as well?
Yes.
Thank you. Would you mind retrieving that? Thank you. Now, Ms. Saylor has pulled up the tank. Thank you. In the back is where, up against the wall, is where that repair weld was. So can you recall from looking at this where you took your samples? And are you looking at a report to help refresh your memory?
No, actually, sorry. Can I look at the actual paint samples themselves? to
Sure,
refresh my memory?
absolutely, yes. We
So-
just have to note on the record if you're referring to something that's not from your memory. So go ahead.
Understood. So items LV6A, LV6B, I believe just LV6A and B were obtained from this side of the tank that you can see in this image. LV6B would have been taken from closer to the weld above that War Ag sticker, and LV6A says it was taken directly above the sticker, the War Ag sticker.
So those were on this side of the tank. And then, so that's A and B.
Correct.
Then we have C, D, E, and F and G. So you took 7 total.
Yes.
So those were from the other side of the tank?
They were either from that end cap of the tank or on the other side of the tank, yes.
So when you say end cap, are you talking about the end cap that's closer to 34? Would you zoom in on that, Ms. Saylor? Are you talking about that end cap?
No, I apologize. I'm talking about the other end cap where it was suspected of being welded.
So which one was taken from that end cap?
Items LV6C and LV6D were both taken from the actual cap itself.
So C and D were taken from the end cap. A and B were taken from above that War Ag sticker. And then the other 3 you say were taken from the on the other side of the tank?
That is correct.
The tank that's the side that's not visible to us in that photograph?
That is correct.
Great, thank you. So then the lab reports that Mr. McCready discussed. So lab report number 12, which I think is what you might be referring to when you were looking at the paint samples. So lab report number 12 was completed on June 25th, 2025, correct?
That is correct, yes.
And you received the items on February 25th, 2025.
That was when the paint samples were collected from the tank, yes.
Thank you. So A to G, those are the samples taken from the tank, and I think you said they're all similar to one another, correct?
The top layer was similar
The
to one
top
another.
layer. Okay, great, and we'll get to that. And then they were dissimilar, though, to 17 and 18. So that would be can 3, and then the lid, or excuse me, the container. There was like a Tupperware container.
Samples 3 and 4.
Yes.
So samples 3 and 4 correspond to my item 17 and 18, and yes, the top layer of the white paints from these LV6 items were dissimilar to those items.
So essentially you had 3 paint cans, and I know you didn't have the physical cans themselves, they were stir sticks. But so you had 3 paint cans and then like a little Tupperware container that had paint in it. And so the Tupperware container and can 3 you said were dissimilar, but you thought these were similar to cans 1 and 2, correct?
That is correct, yes.
Thank you. And then I know you went through the association level, so you reached a level 3 association, indicating that items are consistent and could have originated from the same source, or they could not have originated from the same source.
They could have originated from any source that is similar in all characteristics.
So they all could have come from can 1, right?
Correct.
Or they all could have come from can 2,
That is correct.
or they all could have come from another can.
That is similar to cans 1 and 2, yes.
Thank you. So then you conducted further testing. And that would be report 13. And you received items on March 10th, 2025. You completed the items on July 23rd, 2025, correct?
That is correct, yes.
And this is a situation where you are looking at the layers of the paint?
No, I believe this report included the comparison to the trash can lid, or
Oh.
People's Exhibit
Correct.
237.
Oh, correct. Okay. So you had the trash can lid. That was added in addition to the plastic container and then the paint stir sticks, correct?
Correct.
And then you did this analysis and again came up with a level 3 association, correct?
That is correct.
And then we move on to lab report 14. That's the one where you were looking at the layers, correct?
That is correct.
And that's the one you received items on October 7th, 2025. You did your analysis on January 22nd, 2026, correct?
Yes, that is correct.
And that's the one where they had different, there were different layers, right?
Yes, in this examination, I was looking at the actual layers of items LV6B and E.
So B and E, which are the ones that you would say were probably closest to the repair weld, right?
Correct.
B had a layer of white and gray,
That is correct, yes.
and E had a layer of white, gray, white, and white.
That is correct, yes.
And then you did lots of testing, but at the end, the results were, you came up with 5 different results for your testing: elimination, elimination, inconclusive association, elimination, and elimination, correct?
That is correct, yes.
And you were comparing those various layers to 15 and 16, which are the sticks. Is that accurate?
I was comparing to all of the stir sticks.
All of the stir sticks. Okay, thank you. And that additional testing, did you decide to do that, or did somebody ask you to do that?
I was requested to do that. I had, after completing the 2 prior reports, so People's Exhibit 202 and 203, I had advised Detective Druyer that I had seen additional layers of paint and asked if it would be helpful for me to analyze those layers of paint and do further comparisons, and he requested that I do them.
Thank you. Now, Is there a level of subjectivity to the paint analysis?
I don't believe so, no.
So when you're looking at the peaks, is there anything that two reviewers or two examiners might look at that and come up with a different analysis?
I don't believe so, no.
Were there any different peaks in this case where you had to make a subjective opinion?
No, there were not.
Were there any different peaks in this case at all?
Depending on the paint samples, yes.
Okay, so talk to me about that.
So, of the known stir sticks, People's Exhibit 239 and 296 were chemically similar to one another, so I could not tell the difference between those two, including their infrared peaks. People's Exhibit 297 and 298, they were dissimilar to the other two People's Exhibit 239 and 296. So I was able to categorize the stir sticks into 3 categories essentially. So I was provided 4 stir sticks, and there were 3 different chemistry profiles, let's say, that originated from the analysis of those 4 stir sticks.
So let me ask you a specific question. A is from the tank, and 16 is the stir stick for can 2, correct?
Correct.
Now, what does this mean? Spectre of item LV6A and item 16 had an inversion in their 1385 centimeter-1 peaks, making it look like there were 2 peaks in that region. It has been determined under CR number 12 that this was due to a 1385 centimeter-1 peak appearing in the background being subtracted out of these spectra. What does that mean?
Can you repeat that? I'm sorry.
Sure. And do you want to see that?
That would be very helpful, yes.
Great. It's page 91, please. Mm-hmm.
Okay. Thank you.
So you're the analyst, correct?
Correct.
I saw that. And so you typed those words, right?
Yes, I did.
Okay, so tell us what they mean.
So an inversion means that instead of the peaks going down, there's peaks going up, which is not something that happens frequently, but can happen. Usually that means there's background interference on the instrument. So I can diagnose that as an issue with the background itself, and not necessarily an issue, but something that can occur on the instrument. And because I can see that it happened in the background, and I can see that there are peaks that are inverting in both spectra, or even in one spectra, I can figure out that it came from the actual background that I collect prior to analyzing samples, in which case I know why those peaks are inverting, because that's taking it from the background and adding it to the spectrum.
Is there another reason why peaks might invert?
It's very possible, but not that I'm aware of.
So you made that determination that this was something that was related to background, correct?
Yes, correct, yes.
Thank you. Now, when we're talking about your analysis, you'd agree with me that you cannot come up with an error rate because you don't know the universe of paint cans that could be similar to the samples that you took from the tank, correct?
That is correct.
And I think when you were talking to Mr. McCready, you were very candid. You have absolutely no idea how many cans of Rust-Oleum exist in the world, right?
That is correct.
And there's not, is there a way for you to find that out? Can you ask the manufacturer?
It's possible, but I don't think they would be very frank about how many cans they've created in the past year or so, so I did not.
And you don't know when these cans were purchased, correct?
Correct.
You don't know how many of them were sold in Michigan, anything like that, right?
No, I do not know that.
Do you know if Rust-Oleum is a common paint?
As a homeowner, I know that it's a common paint, but as a paint analyst, no.
Okay, we're good. That's fine as a homeowner too, right? So you can go into Home Depot, Lowe's, Menards, Ace Hardware, anywhere and probably find a can of Rust-Oleum, right?
Probably, yes.
And it wouldn't surprise you that there's probably cans all over Adrian County in people's houses, garages, cellars, barns, everywhere, right?
That would not surprise me, no.
And when we talk about the association scale, the reality is that paint is mass produced, correct?
That is correct, yes.
And it's so mass produced that, again, you can't even designate this to a particular manufacturer, correct?
That is correct.
So we're talking about Rust-Oleum, but it also could be Benjamin Moore, Sherwin-Williams, it could be anyone, right?
It could be any manufacturer that used the same chemical makeup to create their paint, yes.
And when you talk about the paint samples being similar, you, again, can't tell us if we're talking about the universe of similar paint cans being 100,000, 1 million, 10 million, and you're very candid about that. You don't know what that universe looks like, correct?
Correct.
I have no additional questions. Thank you, ma'am.
Does your unit practice peer review?
Yes.
Could you describe that for the jury what it is?
So a peer review is another trained paint analyst reviews all of my work, reads through my notes, looks at my data, and determines if my data supports my conclusions. At that point, they would tell me whether or not they agree with my conclusions or if they do not agree. And they would return it with comments saying these are things I think that would make more sense to clarify in your notes, or these are decisions that you made that I disagree with, things of that nature, and we would discuss the case.
Okay. And were your findings here peer reviewed?
Objection, hearsay. Unless another analyst is testifying, it calls for hearsay.
It goes to the conclusions that she reached and the process that she reached them by. I mean, she can.
So the question was, have they been peer reviewed? Right. So,
And the result, I guess is what I'm asking.
so if you're going to ask about the result, I believe that is hearsay.
Okay.
Thank you.
If it's just whether or not they have been, I don't think there's a statement there.
Okay. So have they been peer reviewed?
Yes.
Okay, thank you. Second of all, you said that there was next to the welds, next to the weld on either side, this gray layer that would appear white to the naked eye. The question is, were you given a sample of something to compare? Were you given a sample of spray paint to compare to that gray layer?
No, I was not.
Okay. All right. And the last thing, Your Honor, if I may, I'd like to publish the trash can lid to the jury at this time.
No objection, thank you.
You may go ahead.
Yeah. That's all I had at this point, John. Thank you.
Any further questions, Ms. Jarvis?
No, thank you, Your Honor.
Okay.
Where the people are concerned, she may be released from her subpoena.
No objection, thank you.
Okay, thank you, Ms. Ponschke, you are free to go.
Thank you.
Will you approach, John?
You may.